Okay, chapter 8, let's go through this. We probably don't have to go through every single one, do we? Because we want to get to a little bit of chapter 10, right? Alright, so let's, geometric mean. Are we okay with the geometric mean? Alright, so watch. Look. Okay, are we paying attention now? Girls? Thank you. Find the geometric mean, so that means you put x here and x here, 9 here and 11 here. Cross multiply, square root of 99, right? Did I make you simplify it? Square root of 99 is what? It's 9 times 11. Because you'll probably have to do this in, whatchamacallit. Let me scooch this. Why is that line through there? Oh, I know why. That's all right. Almost. So it's 3 squared of 11. Okay, good. What about this one? Tell you what, let's move this down. Let's move it down so I don't have that line going through the middle of this. What boxes? What are you talking about? You must be seeing things. All right, here we go. Let's do this. Find PS. This is right there. Now, this is that situation we're going to do the geometric mean. You've got a big right triangle right here. This is the altitude drawn to the hypotenuse. That is the geometric mean. So PS right here, let's just call it X. Is that all right? Just to make it a little easier than calling it. Let's see. So, there we go. So let's see. X is geometric mean, isn't it? Remember this? This is the geometric mean, and so is this one, and so is this one. But they only ask for PS, so but you know that would be a geometric mean. So would this one, so would this one. So this is the geometric mean between what and what? Between the two segments of the hypotenuse, 5 and 8. I'm not going to do like every little detail of this. Okay, I'll just set it up for you. You can do the math if you need to. You've got the answers in front of you. Everybody with me on that? Square root of 40, 2 square root of 10. Yep. We'll do it right here. It's this one. So this is also geometric mean. Okay, the two legs and the altitude are all geometric means. The two legs are geometric means between the whole hypotenuse and the segment of the hypotenuse that's adjacent to that leg. All right, so what does that mean? This is a geometric mean between the whole hypotenuse, which is 11, and the segment of the hypotenuse, right? There's two segments. Because 3 and 8. The whole hypotenuse, 3 and 8 is 11. All right, and the segment of the hypotenuse that's adjacent to that leg. So it's 3 and 11, square root of 33. Make sense? What about this one? Now, y is not a geometric mean, is it? But what's the geometric mean here? 6 is actually the geometric mean. So this time, let's make this a little straighter. This time, the geometric mean is an actual number, not a variable. So 6 is the geometric mean between what and what? Between the whole hypotenuse. What's the whole hypotenuse? Right, it's y plus 4. Okay, it's not 4y, is it? You have to add them together. And the segment of the hypotenuse is adjacent to that leg, which is 4. And the cross multiplication is a little bit more difficult on this one, but you can handle that, can't you? Make sure you distribute. Yeah, 4y plus 16 equals 36, and you're good to go. I'll let you do the rest of that. Everybody with me on that? All right. Let's make this a little smaller so I can see the whole problem. 5 says, find the length of the hypotenuse of a right triangle whose leg... Oh, that's easy. What do you use for that? It's a right triangle, you know, two sides. It's just Pythagorean theorem. That's all it is. Okay, you got to find the hypotenuse. That's the easiest of the Pythagorean theorems, isn't it? Okay, because it's just 6 squared plus 5 squared equals whatever, c squared, and then you just work it out. Everybody all right with that? Pythagorean theorem. What about this one? Well, you had to know something. Yeah, you know this. If this is an isosceles triangle and this is perpendicular to this opposite side right here, then it bisects a couple things. It bisects this angle, and it also bisects that line segment right there. So if the whole thing is 10, what's this? That's 5, right? And what am I trying to do? I'm trying to find this. Of course, that's a right angle. So this is not a special triangle, but what can you use to solve for x? Pythagorean theorem again, but this time it would be x squared plus 5 squared equals 8 squared. All right, x squared plus 5 squared equals 8 squared, and then you can go do the rest and solve for x. Okay, so 5 and 6 are both Pythagorean theorem. 7 is one of those special triangles. It's a 45, 45, 90 triangle. You hate them? Wow. I like them because it makes life a lot easier. Okay, you don't have to do a trig function. All you got to do is look at it and then write down an answer. That's why I like this. Because if it's 45, 45, the only thing you have to know is the relationship between the legs and the hypotenuse. And what is the relationship? The hypotenuse is the leg times what? The square root of 2. And then you're finished. I'll show you the formula sheet after we remind me before class is over. I don't think I put geometric mean on there. Study everything. Well, I don't know if everything. I mean, I just picked selected things that I thought was good to put in. I said I'll show it to you in a minute. Let's keep going. All right, let's solve for x. This is 30, 60, 90 as well. This time, well, this is 45, 45. This is 30, 60, 90. What's the relationship between this? The short side. The short side is the important, okay? Right. The hypotenuse is twice as big as the short side. So if this is 12, this has to be 6. That's right. So what's to hate about that? It's nice, isn't it? It really is. So if I know the hypotenuse, I find the short side. Find the short side, I know the long side. 6 squared of 3. Right? Did I convince you not to hate it now? No? All right. All right, we'll get there. Let's do this one. Find the missing side of a right triangle whose leg measures 48 and the hypotenuse is 50. Now, if you wanted to, I guess you could draw this. But as far as my A, B, and C, right, for Pythagorean theorem, it's a right triangle, correct? What is the hypotenuse? That's the C. And what's this? This is either the A or the B, right? So how are you going to set it up? It's going to be 50 squared. Yeah, 50 squared equals what? Yeah, 48 squared plus b squared, or whatever you want to call it. And then subtract 48 squared. So it's 50 squared minus 48 squared. Take the square root of that. Bang, you're done. Got it? So if you understand it's a right triangle and you know a leg, you know a hypotenuse, do you really have to draw the thing? I don't think so. Okay, you can just put it into this. All right, what about this? The perimeter of a square if the length of the diagonal is 16. Well, we may want to draw this one, do you think? Where'd all my stuff go? Did I click it? I must have. Where'd all my things go over here? My little tools. Windows. Tools. There they are. Wow, how'd I get rid of those? I don't know. Let's see. So, I don't know. You might need a picture for this if you don't really remember how to set this up. So, let's go back to that. Let's draw a little square right here. And what does it tell you about this square? It says the diagonal is 16, right? So from here to here is 16. Now remember, it's a square. We know some things about a square. We know we get a right angle, and we know that this side and this side are equal to each other, don't we? And what are we trying to do anyway? We're trying to find the perimeter, aren't we? So to find one of the sides, you multiply that by 4, and you got the perimeter. Would you agree? So do you remember how to do this? This is 45, 45, isn't it? Because it's a square. Would you agree? This diagonal bisects that angle. So how do you find the leg if you know the hypotenuse? Divided by the square root of 2 this time. So it's 16 divided by what? The square root of 2. I kind of like it like this better. If you get rid of the square root on the denominator, so what do you get? 16 square root of 2 over what? 2. I should put a square root of 2 right there. This is what? 8 square root of 2. So it's 8 square root of 2. That's what this is right there. So how do you find the whole perimeter, though? Yeah, multiplied by 4. 8 fours are what? 32. So what's the perimeter? 32 times the square root of 2. Good with that? I think the square is helpful, or drawing out the square was helpful on that one, don't you? Yeah, because sometimes there's too much stuff to keep in your head. Yeah, but that's what I would do. I would definitely draw out the square there if I was to do this. All right, that was what, 10? All right, what about this? Now this, well, we got to do 11 and 12 before we do the angle of elevation stuff. So this one right here is not one of our special triangles, is it? It's 42 degree. It's not anything special. No offense, but you're not special triangle. Okay. What can we use though? We can use trig functions. So what do we have here? We've got adjacent, don't we? Let's make this a little bigger. Yeah. So we got adjacent and we have hypotenuse, and so we use the cosine. So we use the cosine of 42 equals the adjacent over the hypotenuse. That's an easy one because x is already on top. Multiply both sides by 12. Throw that in your calculator, and then you're good to go. Yeah. I can. What's going on? Am I on a cord or something? Well, it was stuck on a cord. Okay. We got that. This time you're going to actually solve for an angle. The other one we solved for the missing side. Now we solve for an angle. We're going to use the trig functions as well. You can't really use Pythagorean theorem because Pythagorean theorem would only give us the length of this side, correct? But I got to find an angle, so how am I going to do that? This is opposite, and this is hypotenuse. And that's the sine, isn't it? So it's the sine of x equals 6 over 11. So how do you get x by itself? Inverse sine, right. So you do what? It's the inverse sine of 6 over 11. You need to know how to do that in your calculator. Okay, make sure you know how to do that. Yeah, it depends on which calculator you have. Like if you have a TI-30XA, you'd hit 6 divided by 11 equals, you get that decimal, then you hit second function sine, you're done. If you have a graphing calculator or one of those blue ones, hold that up, Jesselyn. If you have one of those, you punch it in just like, thank you, Vanna. You know, do you even know what that means? 33. When I said thank you, Vanna, yes. What's that mean? Wheel of Fortune, very good. It's still on, so yeah, you guys watch it. So anyway, yeah, you would hit second function sine. It gives you a parentheses, 6 divided by 11, close parentheses, equals, and then you get your angle. Make sure if you have a graphing calculator, you have it in degrees. Make sure you hit mode, and it's in degrees. Please make sure you do that, because sometimes they default to radians, and you don't want radians. You'll learn about radians next year in Algebra 2. All right, it's not that bad. Number 13, here we go. 24-foot ladder makes a 58-degree angle with the ground. Well, let's draw the ground first. And how many feet up the wall? That was a little crooked, wasn't it? Let's try that again. Okay. And then here's the wall. Okay. And here's the ladder. Yep. So it's what? 58 degrees? With the ground. Okay. It's not exactly drawn to scale, but it's okay. This is just to get us. And it's a 24-foot ladder. So which one's the 24? The hypotenuse, the slanted one, right. So that's 24. And it says, how many feet up the wall or up a wall will it reach? So what are we looking for? We're looking for that right there. We'll call it h for height. That's all there is to it. That's not hard to set up, is it? Draw the ground, draw the ladder, it makes an angle. Here's the wall. Here's the angle that it makes. It does say it makes, yeah, 58 with the ground. Okay, so that's 58. Yep, this is opposite over hypotenuse, and so it's sine. So it's the sine of 58 equals h over 24, right? Multiply both sides by 24, and that's it. That's all you do for that. That's all you do. 24 sine 58, boom, you got your answer. Yes. All right, let me get rid of that, just so I have some room to write on here. What about this one? Ship's sonar finds the angle of depression to a wreck on the ground of the ocean, and it's 13.2 degrees. All right, well, let's draw that. So here's the ground. That's the bottom of the ocean. The boat's up here, right? So the boat, that's how high the boat is above the water. Now it says it cites what? It finds the angle of depression to a wreck on the bottom of the ocean. So the wreck on the bottom of the ocean, let's say it's right here. So it's making a sight to there. Do you agree? Now you got to be careful. Watch. The ship's owner finds the angle of depression. Which one is the angle of depression? Right. It makes what? From the horizontal, angle of depression would be this one. It would be that right there. So that is the angle of depression. And that's 13.2, which is the same as the right, is the angle of elevation, which is that angle right there. So it's not this one. That's a common mistake people make. Okay, it's from the horizontal. The angle, depression, and elevation is always from the horizontal. If it's depression, it's from the horizontal down. If it's elevation, it's from the horizontal what? Up. You got it? So this is 13.2. That's technically what they're telling you right there. But since that's 13.2, this has to be 13.2 as well. What else it says? If a point on the ocean floor is 75 meters directly below the ship, here's the ship right here, here's the point directly below the ship on the ground. And it says it's 75 meters, so that length is 75. All right. How many meters is it from that point? What point? The point on the ground. To where? On the ocean floor to the wreck, and the wreck was right here. So we're trying to find this. Call that x. All right, so what do we have? We've got, using this angle right here, you've got opposite adjacent, which is tangent. So it's the tangent of 13.2 equals opposite, which is 75, over the adjacent, which is x. Now, what's the math here? Good. Multiply by x, divide by the tangent of 13.2. So basically, you're kind of just switching places, aren't you, with the x and the tangent of 13.2. And you can do the rest in your calculator from there. And that will give you what? That'll give you the distance from the point directly below the boat, the ship, all the way to here. Sounds like that's right. 319? 319? Okay. We okay with that? So, I mean, once you read the, it's really not that difficult to take your picture, or, take the words and make a picture out of it, right? You got a boat, you got a ground, you got a point directly below the boat, you got a wreck out here, and it sees it at an angle, okay? That's what you need to do there. If you like doing that stuff, you'll like physics. Physics is a lot of that kind of thing. Oh, I bet you will if you did it enough. I bet you would like it. Now. All right, 15. Find the angle of elevation, okay, of the sun if a building is 125 feet tall and it casts a shadow. All right, well, let's... Good thing you don't have to be an artist for this, because I wouldn't be able to do this very well, would I? And then, so that's the ground. All right, it says the angle of elevation of the sun if a building is 125 feet tall. So there's my building right there. So the sun's out here, and it's casting a shadow. We'll cast a shadow like that. Does that make sense? All right, so the sun's out here, and it casts a shadow, and the shadow comes along, or the sun's rays are actually going along this angle right here, aren't they? Casting the shadow where? Along the ground. This is your shadow right here, okay? So it says find the angle of elevation. So which one is the angle of elevation? It's always from the horizontal what? Up. So that would be your angle of elevation. We'll call it theta. That's what we're trying to solve for, okay? If the building's 125 feet tall, so it's 125, cast a shadow of 196. Which one of these lines is the 196? The bottom right. You don't see the shadow going through midair, do you? The shadow always lies along the ground, right? Or I guess it could be against a wall or something, but it's got to be against some surface, right? So it's not just like floating in the middle of the air. You don't see shadows doing that, do you? Okay, they're always against the ground right here. So the shadow would be 196. And then it says just find the angle. Opposite over adjacent, tangent, you can do the rest. We good?
Yeah.
All right, what about this crazy one?
16,
Is that good, huh? All right, let's take a look at this one. I guess they give you everything, don't they? Yeah. 18-foot shadow. Find the length of the tree. So it's that slanted one, isn't it? Like, what in the world? How are we going to do that? Let's see. What do we got here? It's 1876. What are we going to have to do? I don't know. There might be. Let's just worry about doing this one right now. This is... We could find this angle right here, couldn't we? Because I know this is 90 and that's 76.
Yeah.
It's not 4 degrees,
So it's...
90 minus 4, so it's 86.
Which one are you saying? This one right here?
No, the one at the bottom.
Oh, I see what you're saying. Oh, I see what you're saying. Right. So this is right. So this is 86 right here. Very good. It's a little thick, isn't it? Let's make that a little bit smaller. Yeah. All right. So this is 86. Is there? Do you understand that? Because that little bit's 4. This whole thing's a right angle. So that's 86. This is 76. So what's that? Give me that, Jesslyn. 18. Is that what it is? I guess I could use a better color than that. But all right, that's 18 degrees. How is that going to help us? This is a lot easier than I'm not seeing it right now because this is actually pretty simple. We have to find how high the tree is. This slanted one right there.
No, don't you have to do the law cosine?
Yeah, because this is not part of a right triangle, is it?
The highest angle is. Do you want to pause it while we figure it out?
Okay, so this is 14 up here. Well, because you know this angle, and yeah, that's right. This one right here is part of that whole big triangle right here. So this is 90, that's 76. So 90 minus 76 is 14. Okay, so that's good. Let's see what else we know. We know this is 18, right? And we got to find this. So let's just... I thought it was... That's what I'm doing. And that's kind of slanted like that. That's pretty close. Kind of. Not exactly, but it's okay. So what is it? What do we got? We got 76. All right, let me scooch this over. And we have 86, and we have 18, right? And that's 18 feet, right? That's the actual length of that side. And this is 18 degrees. Is there any way to find that with what we have? Law signs. You can use law signs, can't you? Because look, I got an angle. Well, I'm trying to solve for a side, correct? Let's make this a little darker. So watch. Here's the law of sines. It's x over what? The sine of 76 equals what? 18 over the sine of 18 degrees. Oops. I think I give you the law of sines and law of cosines. And then you just solve for x, and so what do you do with that? Multiply both sides by the sine of 76, plug that in your calculator, and that gets that length right there.
56.5.
Does that sound right? Okay, good. Why what? Because you use the law of sines. You take the side over the sine of the angle that's opposite, and then we use these two right here. I took 18 over the sine of 18 degrees. All right, so I'm using these two and these two for the law of sines. What's that? We're not?
We don't do 11.
We haven't finished this yet.
I know, I think that's what I need to move.
Let's continue with this. We're doing this one right here. This is going to be... Now, what I would do on this is I would draw the triangle just to let you visualize a little better. What? Yes, what? Yes. They are? Let's just set up 17 and 18. Okay, look at this. It's triangle ABC. Now, angle B is 105 degrees, so you know it's going to be obtuse, correct? It doesn't have to be perfect to scale. But don't do that because it's 105 degrees. And so, I mean, you can. It doesn't matter how you draw the triangle, but you see 105, so you might as well, and that's going to be B, correct? And then angle A is 46. We'll call this A, that's 46 degrees, and this has got to be C. So side C is 19.8, so this one is 19.8, and I believe that's everything, yeah. And we're trying to find what? A? We're trying to find that. So how do we do that? Well, let's see. Can we use? Yeah, you can find this angle, then use the law of sines, or you could find this angle and use the law of cosines, couldn't you?
I don't know. Which one do we want? It's easier to do the sine.
Is it? Okay. So what is this angle? What's 180 minus 105? That's 75. Minus 46 is 29. Is that right? 29? What did I say? You sure? So let me double check. Do it again.
That's just what I got on my test. I got
75.
Right,
Oh, 75. I was thinking 4. I don't know why I was thinking 4. Right. So it is 29. You're right. All right, and then you can use a lost sign. So what would you use here? I would go A over the sine of 46. Correct? Those two right there. And then you got to have two that you actually know, so I'll use these two and then put the side on top, 19.8 over the sine of 29. And then multiply both sides by sine of 46 and you got it. Okay with that? All right. Let's set this one up. Here's another one. 108 degrees, so it kind of looks like the same triangle, doesn't it? Let's blow this up just a little bit. So we'll call this 108 degrees, and that's angle N. What else do we have? So this is N, so this is little n, correct? We'll call this little l, and we'll call this little m. So L is 42, M is 61. So what does that mean about the other angles? This has to be what? Angle M, and this has to be angle L, correct? Because it's opposite those sides. And what do they ask for? They ask for this. Oh, this is set up perfect for law of cosines, isn't it? Remember, I've got a side angle and a side. You remember learning that? That's where we use law of cosines. Whoops. So here's the formula for law of cosines. C squared equals a squared plus b squared minus 2ab cosine of c. All right, if I use this as c, these have to be a and b. All right, and this has to be the angle that's opposite this side right here. So if you, all depends on what letters you use. So what's our c here? It's actually an n, isn't it? So it's going to be n squared equals 42 squared plus 61 squared minus 2 times 42 times 61 times the cosine of what? 108. Doesn't matter what. Because this side has to be opposite this angle. Doesn't matter which one you call A, B, or C, but this side has to be opposite this angle. So these two, that has to be the one that's by itself, because this is the only angle that we know, right? So I have to take the cosine of this angle. So this side has to be the one that's opposite this. And these are just your other two. Doesn't matter. Doesn't matter what order you put them in or anything. What's that? Probably. Yeah.
How do you know, like, to do that for the portion?
Because there's no way you can do lost signs, because you have to find this side. Remember, you got to know 3 of the 4 things, right? If I do this, I have to know a side and its opposite angle. I don't know any of the other opposite angles, so there's no way I can use lost signs. And we also learned another way for law of cosines. We said it was either side, 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 or side, angle, side. Anybody listening to me? Everybody's like eyes are everywhere else up here. When you use law of cosines, it's side, 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 or side, angle, side. That's when you use law of cosines. Cosines, and then use law of sines otherwise. Yes. What? Yeah, that's what we're about to do. Magnitude of the vectors. So you've got negative 2, 2, and you've got 3. What's up with what? I know, people take them. I don't know.
Why would you want to take them?
I don't know. They lose them. They do. I don't. Who knows what they do with them? I've only had like 15 passes, and right. I don't.
Because you don't have to go to class and you can wonder, like, just do them post it.
All right. Let's not worry about that. Let's do this. Find the magnitude of this vector. So what are we doing? Find the distance, right? So let's kind of visualize what's going on. You don't really have to draw this out, but just it's been a long time since we've done this, so let's figure out. Negative 2, 2 is right there, and then 3, 1 is right there. And so what we have to do is find out how long that line segment is from here to here. That's the magnitude. Exactly right. And that's the distance formula, isn't it? So just use the distance formula for that. Well, we'll talk about that in a second. Let's do worry about the magnitude first. So the distance equals the square root, and I know, but I need the number. And then you do this. So x1 minus, so it's 3 minus negative 2, which is 3 plus 2, which is 5, and then 2 minus 1 is 1, so that's 25 is 26. Square root of 26, right? Yeah, square root of 26, like I said. I would rather use this number right here. All right, so that's the magnitude of the vector. Find the direction of it. Now remember, it's vector WZ, so it starts at W and goes to Z. Which one was the W? It was this one, right? And it's going this direction. Agreed? Let's make this a little bigger. So this is the direction that it's going. That's important because it says find the direction. You have to know, is it going up like this or is it going down like that? So what we're going to do is draw a little triangle. There. Did I go far enough? Yep. Maybe not. Yeah, we'll say there. Okay. So what am I trying to find? I'm trying to find that angle right there, aren't I? Okay. Let's see. Is that the angle I want? Yeah. Yeah, that's. Tell you what. Let's do this. Let's make this in black. Remember we drew a little x and y axis here at that point. Remember doing that?
Yeah, I got this one because I didn't understand it.
Okay, look. So what am I really trying to find here? Let's go green again.
The big angle from.
I ended up getting it right though.
Well, just spread your numbers out a little bit so this angle's a little bit more, because you're only going down 1, unfortunately. It would be nicer if it was a little bit of a steeper angle, but it's not. But so what's the angle we actually want to find? We want to find from here all the way to there. Okay? Everything but that little chunk right there. All right, that's the angle that we want to write as our answer. So what I'm going to do is I'm going to find this angle right here because it's inside my triangle. That's right. And in order to find, yeah, I could go like 270 plus this, right? Because remember what I'm doing. I'm going from here all the way to here. So I could go 270 plus that angle right there, couldn't I? All right, so that's really what I'm trying to do. Well, you know some stuff. You know the lengths, right? You know this because here I am at is it 3 or what am I at? 2 and 1, right? Yeah, I'm here at 2 and 1, so that's just a 1. And what am I here? I'm from -2 to 3, which is what? 5. All right, and that's how we got that square root of 26. So how do I find this? I could use any of the trig functions now, right? Now I know I know this one, my hypotenuse. I could use any of them. Let's just use the 5 and the 1. So it's opposite over adjacent, which is the tangent. So the tangent of this little angle right here is equal to 5 over 1. Take the inverse tangent, and you get this angle right here. What's the inverse tangent of 5? So let me do that. 78.7. Okay, so let's get 79. Let's say it's 79. So this angle right here is 79. What's my actual angle that I want? I want, well, let's do it a little easier. Let's go 270 what? Plus this little bit, right? Because from here to here is 270 plus the thing that we just found, which would we say is 79 degrees. So what's 270? Oops. 270 plus 79. What is it? 349. Was that the angle? And there you go. And that angle right there, see that big old loopy angle right there? That's the angle that you want to find. Okay? I don't know what it says. I don't have it in front of me. Well, I guess I do have it in front of me. It doesn't say, so the whole number is fine, especially with the angle. It's fine. That would be the direction, correct. 349 degrees would be your direction. Okay. Yeah, I'll show it to you. All right, with the circles. Wasn't that circles? All right. I mean, you could always go back and look at the review for the actual test that we took and all that kind of stuff, right? I've given you plenty, I think, to get started on. I put it somewhere. No, I think it might be under CP. Formula sheet. I just made this for the CP class, but I'll give it to you guys too. I don't even know if it'll help you or not, but you might know a lot of this stuff already. So here's the everybody looking here. Here's the formula sheet that I'm going to give you. 6, 7, 8. I don't have 10 in there. I don't know why I have 10 in there. Well,
I'm sorry.
you me take them off of there? Okay. So I just picked a bunch of stuff. Okay. This again, I made this originally for my CP class. So, if you think it's underneath you, then don't. All right. So that's all the stuff I gave you. So look, I give you this stuff for 45, 30, 60, 90, the sum of the interiors. I tell you the sine, cosine, and tangent, which you should know. Law sines, right? Law cosines. Give you area stuff, right? That's good. Look, even the area, kite, and rhombus, area of a trapezoid. What did I just do there? Let's get this away from that test. There we go. All right. Yeah. Those weren't really formulas. These are formulas. Yeah, area of a circle is pi r squared. I couldn't, for some reason, it didn't give me the pi button, and so I put question mark. So it's pi r squared. You know that, right? Here's that. Remember that similar triangle thing we did with the similar polygons, the areas. We did that. I could have, but I didn't.
Okay. Wait, when?
All right. So, well, at least it shows you. So at least I give you law sines, all cosines. You're crying about that, right? So I gave that to you. Give you some area stuff. 45, 45, 30, 60. I give you those things, all right? So that's nice. So that helps a little bit. All right, well, that was it. Study hard for this, okay?